Hello everyone, I hope everyone's doing well. In today's video, we're gonna solve a single shear stress problem. In this problem, we're gonna be analyzing a structure that consists of a horizontal member and an inclined member. This inclined member is a supporting strut that is being positioned at a 50-degree angle with respect to the horizontal member. The dimensions of the strut are 0.25 meters for its thickness and 0.5 meters for its width. Knowing that the allowable average shearing stress of the glue at the point of contact between the horizontal member and the supporting strut is 500 megapascals, we need to determine the maximum force F that can be applied to the system. Now that we have already discussed all the given information and all the required, we can just go ahead and start solving the problem. In this problem, our point of focus should be at the point of contact between the horizontal member and the supporting strut. So, the first step in the solution will be to make a cut at the contact point. This is with the purpose of analyzing the internal loading in the inclined member. Okay, now that we have made the cut and drawn this section AA, we're ready to start drawing the internal forces of the member. In this member, we have the shearing force, the normal force, and the bending moment. Although the normal force and the bending moment are no zero values, we're not gonna focus on those values in this problem. We're only gonna focus on the value of the shearing force. And to obtain the value of the shearing force, we need to first define our coordinate system and then apply the equilibrium equation along the x direction. In this case, acting on the x direction, we only have the shearing force and the x component of force F. And in this case, our shearing force will be equal to the force F times the cosine of 50. Since we don't know the value of F, I will just leave it like that for now. And I will name this as equation 1. Once we have an expression of the shearing force, we can move on and apply the concept of single shear stress. Our equation for the single shear stress will be tau equal to V divided by A. In this case, V is the shear force and A is our cross-sectional area. In this case, we don't know what the cross-sectional area is. So let's go ahead and find it. In order for me to do that, I will draw a portion of the member so we can apply all the geometry and solve for the cross-sectional area. Since the area of the bottom is our area of interest, we need to find the value of the base. By drawing a right triangle, which is the bottom portion of the member, if we recall from geometry, we know that sine of theta is equal to the opposite side over the hypotenuse. In this case, our theta will be 50 degrees, our opposite will be 0.5, and our hypotenuse will be b. If we solve for b, we know that b is equal to 0.5 divided by the sine of 50. Now, once we have the base, we can obtain the area by multiplying the base times the thickness, which is already given. We obtain that the cross-sectional area is 0.1632 square meters. Now let's go ahead and plug the value of the area into the shearing stress equation. Once we have plugged all the values into the equation, we can see that the only unknown in this equation will be F. So the last step to do is to isolate F and find it. Once we solve for F, we have to multiply 500 times 10 to the 6 newtons over meter squared times the cross-sectional area, which is 0.1632 square meters, divided by cosine of 50 degrees, and that will be the maximum value of the external force F. In other words, our maximum allowable value for the force F in this problem will be 126.95 meganewtons. I hope this video has helped you understand the concept of single shear stress a little bit better. If you found this video helpful, don't forget to subscribe to my channel and give this video a like. And if you have an additional question, just post it on the comments. Thank you so much for watching.